Hello everyone. Today we are going to discuss about our first chapter in chemistry, matter in our surroundings. Actually, first of all you should know what is matter. Can you see this red ink? This is a matter in the solid form. But inside the pen you have, or inside the marker you have a red ink that is in the liquid form. But now I am doing respiration. I am taking oxygen through inhalation. Oxygen is a gas. So, dear students, in our surroundings, we have matter in different physical states. So, matter should have a space to occupy and matter should have a mass. Matter should have a mass. Okay? Now, I would like to share with you some points, some important characters of matter. The first point is matter is made up of particles. In every matter, you have particles. That particles are very small. That is the second character. The particles of matter are very small. It is small. It is beyond our imagination. That much small a particle inside a matter. And next character, particles of matter have space between them. Can you see air? Actually we cannot see air, but we can feel air. If you move your hand very fast, you can feel. If you switch on a fan, you can feel the presence of air. The movement of air is known as wind. So, air has a mass, but in the air, the particles have more freedom, more spaces. But in a glass of water, the space between the water molecules are little bit less. But in the water vapor, the spaces are large. There is a large spaces between the water molecules if the water is in the water vapor. If you are taking water vapor, you have lot of spaces between the water molecules. But if you are taking an ice cube, what will happen? Can you see much spaces? Actually, we cannot see the water molecules. But using some advanced techniques like electronic microscope or spectroscopy, we can analyze the water molecules are closely arranged in an ice cube. So, in the solid state, the particles are closely arranged. But in the liquid form, the particles have little bit space. But in the gaseous form, there is a lot of space between the particles. As a generalization, we can say particles of matter have space between them. Then the last character, we have some more characters. Particles of matter are continuously moving. Dear students, particles of matter are continuously moving. Again, I am comparing the gaseous and liquid and solid form of matter. In the gaseous form, the particles of matter are continuously moving. In the gaseous form, they have more freedom. The particles have more freedom in the gaseous form than in the liquid form or solid form. So generally we can say particles of matter are continuously moving, but that movement is restricted in the solid state since the particles have no space to move. So solid state, the last 2 points are restricted, but in the liquid state or in gaseous form or in the gaseous state, the movement is little bit high. Compared to liquid, gas particles can move everywhere. So, the particles of gas substance or a substance in the gaseous form have more freedom. They are continuously moving. We can take in our kitchen, we have liquefied petroleum gas. In that LPG, the methane particles are continuously moving without any direction. because that methane is a gas. That methane is a gas. They have more freedom to move. They are continuously applying pressure on the walls of the cylinder. So the gaseous particles have more freedom. They can diffuse from one place to another place very fast. That diffusion is very fast. If you apply an air refreshener or air freshener or a perfume in your room, in your dining hall, what will happen? That will spread out. The all over the room or all over the house may feel the smell of that perfume, because inside the perfume, whenever the perfume come outside, the particles are getting more freedom to spread, so they will move from higher concentration to lower concentration. That is known as diffusion. Dear students, don't forget, diffusion is a phenomena. Diffusion is a process where the particles of matter, especially in the gaseous state, are moving from higher concentration to lower concentration. That is known as diffusion. Diffusion is a character of the particles of matter. Solid, liquid, gas, both can diffuse into liquid. If you mix salt or sugar in water, diffusion will happen, because the solid components of sugar and salt will enter into the spaces of the water molecules, because you are mixing salt and sugar with water solution or water solvent. So diffusion will happen. My dear students, if you are making soda or carbonated water, you should have to pass carbon dioxide into water. At that time also the diffusion happens, because CO2 will enter into the spaces of water molecules. That is also diffusion. So, and if you are mixing acetic acid, vinegar into water, or lemon into water, diffusion will happen, because the acetic acid or vinegar will enter into the spaces of water molecules. So diffusion is best for gaseous substance. I told you, if you apply perfume in a room, within few seconds the smell spread all over the room. That is the best example of diffusion. So I'm telling to you, dear students, I'm telling to you, solid, liquid, gas can diffuse into liquid. We have to discuss some more characters of matter. The next character is particles of matter attract each other. Actually, inside the matter, especially in the solid state, particles are closely arranged. And in the liquid state also, the attraction between the particles are little bit high. So in the solid state and liquid state, the particles of matter are attracting together, are attracting each other. But gaseous state is an exception, since gas molecules or particles have more freedom to move. Okay, so particles of matter attract each other. These all points are like generalization. So on the basis of different physical states, scientists were established these characters. So we have one more character here. Particles possess kinetic energy. Do you know, in the gaseous state and in the liquid state also, the particles of that particular matters will possess more kinetic energy. But in the gaseous state, that kinetic energy of the particles are maximum, but in the liquid state it is little bit minimum. But in the solid state, the kinetic energy is restricted because of the close packing of the particles inside the solid state. But if you raise the temperature, when temperature increases, kinetic energy also increases. If you increase the temperature, the kinetic energy will be increased. If you increase the temperature of a normal water after attaining the boiling point of water 100 degrees Celsius, it will be boiled. At that time, the kinetic energy of the water molecules are maximum. So from ice cube to water, then water to water vapor, if we are raising the temperature, the particles will get more kinetic energy. Their kinetic energy is on maximum value. So I am telling to you, in the case of particles of liquids as well as gas, they have more freedom to move. They have more kinetic energy. By raising the temperature, we can increase the kinetic energy of the particle. So we discussed today the introduction part of our first chapter, matter in our surroundings. Thank you for hearing me.